questions?
That's good stuff, good stuff. I like that one. Oh yeah, that's the one I was doing. I ate my lunch within like 10 minutes. I like scarfed it down. Because I was studying for this quiz. And usually I don't wait to get lunch.
Okay.
Until like 12:30. Number one. Yeah. Everyone goes at 12. It's right at 12. Yeah. Mm-hmm. I remember going there at like 3 or some random time. We just passed it. What in the world? These people from go home.
Kurt, help me out here on this one. You have a resistor here, right? This is 6.26, and then you have a capacitor here? Never mind, I'll just This is V out. All right. That's the circuit, and they give you a voltage is 24, it's an angle of 60 degrees volts. You assume it's peak unless it says RMS.
Yeah.
So what I tell you to do, the ratio is 1 to 2, I believe, right? Is that right? And then here you're going to have, this is V1 on the primary, this is plus or minus V2 on the secondary. The positive always goes with the dot, right? When you think about this, I know since it's 1 to 2, V2 will be twice the voltage of V1, correct class? And by the same token, I know the current in the secondary flowing into the, I should put an I1 here and an I2 here. I know the current flowing into the secondary would be 1/2 the current flowing into the primary. The higher the number of turns, it goes 1 to 2, voltage up, current down. Follow me? The product of the two remains the same. Now, they're asking you for V out. How do you want to get V out? I'm going to make a suggestion. Simplify the circuit as much as possible before you start writing just loop equations. All right? To do that, you all agree I can get a single element to replace those two. Since they're in parallel, I can say I can replace these two elements, right? I'll call it Z equivalent, where it could be 1 over the first impedance, 1 over J2, and then it's plus 1 over minus J6. This is one way to do it. Do you all agree with that? Class? Now, it might be easier to do J1, or first impedance, second impedance, first impedance plus second impedance. I'm going to do it that way. This isn't, you can do it this way. But if I take this, it would be J2 times minus J6 over the sum of the two. Can everybody see J2 minus J6 is just going to be minus J4? You all agree with me there? Please make sure you do. You all see this, class? I'm multiplying the first impedance by the second over the sum of the two. You agree with me that that's the equivalent impedance? Everybody? Give me a show of hands there. Do you all? Okay. So if that's the case, you see I can get rid of minus J right there. Everybody see that? And then what can I do? Well, I've got 4 and 2 is a half times 3, or I mean a half times 6 is 3. Do y'all agree with me? So that's J3. So right off the bat, now please be attentive here. I'm trying to show you the way I would do this. It's simplified before I write an equation. So this becomes simply J3 right here. Everybody got that? You understand why I did what I did, right? To make it easier on myself. Don't make it harder. So this becomes simply J3. All right, now over here, I can do likewise if you think about it. Can everybody see what I'm up to right here? I want to simplify that circuit. I've got 2 loops here. Do I need 2 loops? Not really. I'm not looking for anything on the primary. So to simplify this, I'm going to take this and make it a current source in parallel with a resistor. Now, I don't know how he does it in the solutions manual. Who asked this question? Who asked? Did you ask this? Who asked this question?
I did.
Sure. Okay. This is a pretty good problem because it makes you use all the tools, in my opinion, out of your bag. All right, now I'm going to simplify this. So I'll make this a current source of 6 at an angle of 60 degrees. Y'all agree? In parallel with that 4 ohm resistor. Wow, what was it, 30 degrees? 60 degrees? All right, in parallel with 1 ohm. You don't have to do it this way. Or, sorry, was it 4?
4.
4, yeah. Now, I've got this, correct, class? You with me? Now, this this element, right? These two become one element, they're in parallel, correct, class? Yes, sir.
How did you get J3 over there? I'm not understanding.
All right, back in the day, we had, it was J2 and minus J6, right? All right, if you multiply them, you're going to have J2 minus J6, then you sum them, right, and divide that. So it'd be minus J2 plus, plus J2 minus J6 or minus J4. Minus J into minus J on top cancels. 2 by 4 is 1/2. 1/2 times 6 would be J3.
What happens if you do it the other way, the way you showed us?
This will show up the same way, it gives you the same answer. You can do it this way in your calculator. They're the same.
But if it were that way, wouldn't it be, like the bottom would be, negative J4?
No, wait. Yeah, but when you take 1 over that, what do you get? J3. Just do me a favor, do this calculation and see if you don't get that.
I did, that's why I was asking.
Oh. Well, I'm suspect to do something wrong. I really didn't want to mess around with this much, but is this right, class? Can anybody?
Yeah.
That's right. All right. Now, is this right?
Yeah.
Yes, right? Now, what can you do with this? Can I multiply top and bottom by, just do it this way, top and bottom by J2 for starters. Do you agree with that? If you do that, what do you have? You get J here, right? By J2 makes that 1, right? Multiply this by J2, I have 2 divided by 6 or 1/3, right? But it's a minus. Ah, there's a J there. I'm gonna mess this thing up. Keep doing it.
Why can't you add those at velocity as they are?
Well, that's 1 over 6, that's 1 over 2, right? If you want to get a common denominator, you're going to have to get, see, I take the minus J upstairs, positive J, the J here upstairs is minus J. You can fuss with this, it comes out the same, you're going to have to trust me. Can you see me after class about this?
Okay, yeah.
Before I mess with this.
Yeah, sorry.
I want to get back to this problem, and I'll be happy to do it for you, but trust me, they come out the same. Now, coming over here, if you look at this, these two are like one element. Do you agree with me? So if I take those two, if I want to make it a single element, I can, can't I, class, if I wanted to? And that would be 4, well, I'm going to do it this way. 4 over minus, or times minus J4 over 4 minus J4. That would be the Z common right there. Do you agree with that? Now, if you look at this, right away I can divide top and bottom by 4. And that makes this 1 minus J1, Correct, class? Now when I have that, I know what this amounts to. This is simply going to be the square root of 2 at minus 45 degrees. 1 minus J1 is the magnitude of square root of 2. The angle is going to be minus 45 degrees. And I'll put that in this, so I have square root of 2 at an angle of minus 45 degrees. When I take that upstairs, the angle, this becomes simply 1 at an angle of 45 degrees here. Minus J is minus 45 degrees, or 1 at an angle of, minus 90 degrees. Are you with me, class? I'm just doing this, going through the motions. Right? Now when I do that, what do I get? That's net minus 45 degrees. Do you agree with me? Right? So this is going to be equal to 4 over the square root of 2 at an angle of minus 45 degrees. Is Z common? Now what I'm going to do, I'm going to draw it over here so you see it. Y'all agree with me there, by the way? Y'all see what I'm doing? I'm trying to do it easy. I'm trying to make it an easy thing. When I take a look at this, since this and this is equal to this, do you all agree with me there? How many do, please? All right. If you do agree, then I can take this, and multiply it by this to get a voltage, right? What's that voltage going to be? If I take 6 at 60 degrees times that, 60 minus 45, you all see what I'm doing here? Right? So that's going to be what? 25, right? You follow me what I'm doing? I'm going to take 60 times this, right? I'm going to take 6 at 60 degrees times this. Well, 6 times 4 is going to be 24 over square root of 2 would be the magnitude. And the angle here is going to be 60 minus 45, so that'll be 35. Do you agree with me, class? So that's going to be 25. Now if I have that, I come up here and I put that impedance in series with it, and I can just leave it as this a block. So 4 over the square root of 2 at an angle of minus 45 degrees. Now it goes into the primary side. Now the problem breaks right down for us. This is the dot, this is V1, this is I1 here. Come on this side, it comes down. Here's the dot here, plus or minus V2 on that side. That's current I2. Over here, the impedance is going to be, and that's 12 plus J3. J3, and this is where the V out is, plus or minus V out that you want. Does everybody agree? Yes, sir.
I got the correct magnitude, but when I did 2 minus 2i, which is the resistance, and then you multiply it by the...
2 minus 2i, where
yeah,
we?
keep it in rectangular. Like, say you multiply...
You're talking about that?
Yes, sir.
Zcon?
Yeah, that's 2 minus 2i in rectangular. When I multiplied it by the 6 angle of 60, I got the magnitude, which is 16.9, but I got an angle of 15.
Actually, you're right. My math is suspect today. You're absolutely right.
Why is it negative?
It's just this plus this, or 60 minus 45. 60 minus 50 is 10.
Positive 50.
Plus 5. No, yeah, it should be positive 50. I'm 15. I'm sorry about that. But you're right. I'm not really worried about the angle, but you're absolutely right.
I want to make sure I'm doing it right.
You're right. You're right. You guys got me on this one, don't you, class? All right, now I come over here, and it's 1 to 2. Now here's how I'm going to do it. You could write equations for current voltage, but you don't need to. Here's the deal. The only thing I need to know is what the impedance of that coil looks like. All right? You remember what I told you about reflecting impedances, class? How many do? When you reflect impedance, right, from the secondary to the primary, it's the turns ratio squared. Now, hear me. The higher the turns ratio, the higher the impedance, all right, on this side. When it goes to, do you all follow me on this one, class? As a matter of fact, let me just do this so you can see. When I take a look at this, I know that V2, right there, is equal to 2V1 based on the turns ratios. Do you all see that? All right, now I also know that I2 right there, I2 is going to be 1/2 I1. Follow me? That way the product remains the same. V1 times V2 is I1 times I2. It has to be because it's the same power on both of them. All right? It'll always be conservation of power on these things. Now if that's the case, what's the impedance on the primary side? Well, if I look at this, right, V2 over I2 is the impedance on the secondary. Do you agree with me? So Z load on the secondary is V2 over I2. Now keep going and look at that, right? What's V2? It's 2V1. Divided by what's I2? It's 1/2 I1. Or I could say that the load impedance right here is equal to, and this is going to be 4 V1 over I1. Y'all see this? So what happens? That V1 over I1 is what the impedance of this coil is, correct? That means that impedance is going to be what? That's V1 over I1. It means Z on the primary side, that's looking right here, would be equal to the secondary side, Z load over 4. What it really is the load impedance divided by the turns ratio squared. Do you follow me? Give me a show of hands if you can see this. I've done this before. You can see that what happens is, you can think of it this way: voltage less, current more, impedance must be less. By how much? By a factor of the turns ratio, 1 to 2. So it's 1 over 2 squared, or turns ratio squared. So what I'm really getting at is when I'm looking at the primary circuit here, right here, what I can do is replace this coil with the reflected impedance. And what reflected impedance? I would have 12 plus J3, follow me? And I would divide that by 4. Does everybody see this, class? Give me a show of hands if you see what I'm doing. So now I can say that right here, I have 24 over the square root of 2 at an angle of 15 degrees as the source voltage. Then I have an impedance here, and rectangular, it's is that 2 plus or 2 minus J2? Is that what you said?
Yep.
2 minus J2, and then I put my reflected impedance, and that's going to be equal to that, which is 12 plus J3 divided by the turns ratio squared of 4. And then I'm going to get I1. Do y'all follow me what I'm doing here, class? The only thing I'm doing now, I've reduced the complexity of the circuit. This is the way I would do this problem. I'm taking a lot of time doing it. I'm trying to make sure. Only thing I've done, that's the voltage, right? After we did the source transforms to get to this point. Now we have one loop in the primary. That's the impedance from the primary circuitry, right? That's on the primary side. This is the reflecting impedance from the secondary, correct, class? Everybody see this? I want to make sure you do, correct, class? Now we can get this current right here, I1, very easily, right? That's just going to be that voltage divided by the sum of these two. And by the way, what do I get for this? Well, it's really 3 plus J3 fourths, if you wanted the truth, right? So can somebody just tell me what you get for I1? If you add this plus this and divide that into 24 over the square root of 2 at an angle of 15 degrees, what do you get? Anybody? Sorry, can you? Anyone? I mean, you see this, don't you? I'm trying to just reduce the whole goal is make it as simple as possible. You don't want to have to write 3 loop equations. That's a waste of time. Anybody? I mean, if you want to, just put 3 plus J3 quarters right there. Right?
I think it's 3.3 at an angle of 29.
3.3 at an angle of what?
At an angle of 29.
29 degrees. Anybody else get that?
I got it.
29 degrees, thank you. How many got that? Just show hands. Not a whole lot. Get your calculators on, you're gonna be doing it today. Might as well learn how to use them really well. All right, so if it's 3.3 at 29 degrees, now think that's primary side here, right? Secondary, voltage steps up, current steps down by a factor of 2, right? So you would take I1 and divide it by 2 to get the current in the secondary. Do you all see that? So what would that be? That means I2 would be equal to 3.3 by 2 at an angle of 29 degrees, right? If that's correct. Follow me? Now that current is what? That's this current flowing this way. Understand, everyone? Now if that's the current flowing this way, but I want this voltage, what do? Well, I would take minus that current technically, wouldn't I, class? Because it's going the wrong direction. How many see that? Minus the value of this current that's right there, times J3. So I would say V out there, right, would be equal to minus this value, or minus I2, whatever it is, times J3. And what's that value gonna be? Just do it. What is that? 1.6025 or 0.05? Anybody? Come on, people, help me. Say again?
I got 0.896 at an angle of 105.
0.896 at an angle 105, did you say?
Yeah.
Anybody confirm or deny? Anybody? What? You didn't get it? What's some other answers? What? Say again, say it louder, I can't hear you.
I'm not confident.
It's not hard, J3 times that, all right? So 3 times 3, wait a second.
4.93.
What?
4.939.
That sounds better.
Of negative 16.
I believe that. 4 point what?
4.939 at an angle of negative 16.963.
Huh? How many got that? All right, is that the answer? Is that the answer in the book? The solutions.
4.9 at an angle of 190.
All right, add 180 and, well, you put a minus on it. You got a minus there? Did you say a minus?
No, it's positive 190, but I don't see a negative sign.
Is this, now correct me if I'm wrong, is this the polarity here? Yes or no?
Yes.
Yes, it is, so.
I don't know. Well, I'm gonna suggest to you that the magnitude's right, and I think the angle is wrong, unless we've done something wrong mathematically here, because the concepts are clear. The idea is this: get the reflected impedance, then find the current flowing in the primary into the dotted terminal, take that current, take into account the effect of the turns ratios. It reduces it by a factor of 2. Since that means this current is flowing this way, I have a feeling it's an error in the book. This current is flowing this way. If we want this voltage as shown, then it's going to be minus this current times I3, because you want the current flowing into the positive terminal. Yep.
This is a conceptual question. In some of the answers that you posted online, when they do these transformer problems and they get down to the complex matrix, they're multiplying it by 1 over the difference of.
Now, 1 over the turns ratios, you mean, right?
No, it's.
Oh, no, he's doing Kramer's rule.
Okay.
Kramer's rule always requires you get a determinant of just the A matrix first.
Okay.
You're going to divide that into the original matrix, but then you take the row. If you wanted the first current, you would take the first row and replace it with the B matrix. And then you take the determinant of that. If you haven't done Kramer's rule in a while, don't worry, but that's what he's doing. That's what he's doing. Any other questions about this one? Yes?
So I'm confused about the the ZP, how we get that value.
That's the reflected impedance.
I don't understand how
Well,
we get that.
if you
feeling.
go, here's the simple way to do it. More turns, higher impedance. Less turns, lower impedance. But by the square of the turns ratio. The turns ratio is 2. Do you see it? The lower number of turns is here, right? It means it's going to have less impedance on this side by 1/2 squared. Got me? All right, what is the impedance that's going to be loaded? It's going to be this impedance. So you take the load impedance, 12 plus J3, and divide it by the square of the turns ratio. Turns ratio is from primary to secondary. All right, so in this case, it's 1 to 2, it's 2. Divide by 2, it's 4, right?
Right.
That's the reflected impedance.
Okay.
If I was on this side and I wanted to reflect impedance, forget that source there, then I would find the impedance here, and I'd multiply it by n squared.
Okay.
Put the impedance on that side. Got me on that, class?
So when we're doing that, we don't include the impedance by the transformer coils, it's just everything.
There is no impedance shown. Take a look. Those are transformer problems. There is no mutual coupling. There is no J omega L1 and J omega M. All right? This is a transformer problem. The coupling is perfect. You don't have to worry about coupling. You don't have to worry about those coil impedances at all. That's the bottom line. Yeah.
How did we get 3 plus J3 over 4? The primary.
Right here, we had, this circuit had this impedance in the secondary, correct? All right, it's 12 plus J3, right? What is the turns ratios? 1 to 2 or 2? Right? Squared is 4, right? Take 12 plus J3 by 4. You get 3 plus J 3/4. Right? Just take 12 plus J3 and divide it by 4. Sorry if I didn't make myself clear. Got it?
Yeah.
Any other questions about this one? I want to do another one too, brother. I want to make sure we're clear on that. Anybody?
You want to do a different problem?
I can't hear.
Are you asking for an additional problem?
You've been a great source of problems. Yeah, sure. You got one for me, please? Yeah, I'll be happy to. Which one? Remember I gave you several other, right, with power?
The last one, 6.28.
Fine. Which one did you want? 2.8, did you say?
Yes, sir.
All right. Now this is another one we can reduce. We'll do this, all right, that's an amps. What he wants is BS from this one. And the turns ratio is 2 primary, 1 secondary, okay? Now he gives you I2, right? But you'll notice I2 is doing what? It's flowing out of the dotted terminals, correct? The actual value of I2 flowing that way would be -4, agreed? Everybody see this, class? How many see this one? You see what I'm talking about? This current's coming out of the dotted terminals. We want the current going in. This current, why don't I call this I2 prime? I'm gonna call this I2 is equal to either -4 or 4 at an angle of 180 degrees or -180. I'm gonna just leave it as -4, it's easier. All right, correct, class? Now, take a look at this. Less turns here, more turns here, right? Less current here by 1/2. Follow me, class? It's gonna be a factor of 2, it divides by. It means the current coming into this one is gonna be -4 by 2, or just -2 amps. How many see this here? You understand what I'm doing? You all see it, class? I gotta make sure I'm talking, I mean, if you do, let me know so I can read you right. Okay, you see it? Yeah.
I thought you said it's squared, but.
No, that's impedance, right? Impedance is squared. Current and voltage are linear, proportional to the turns ratio. Got it? Impedance is squared. All right, now take a look at this. If that's -2 amps flowing this way, correct? We're almost there. We still need this voltage, don't we? I still need V1, don't I? Correct? Because if I got this voltage, I can add this voltage drop to it, correct, class? Matter of fact, why don't I do this just to make sure everybody's okay? Why don't I go ahead and reverse both of those currents? Because if you reverse one, you reverse the other, and get rid of the negative. That'll make people happier. Are you with me? You all see what I'm doing? Sure, I'll just have this, instead of making this -4, have it go this way, and make it equal to 4, and then reverse this one too. Instead of -2, it becomes 2 this way. Agreed, class? You all see what I've done there? If you switch one, you gotta switch the other. They're either both into the terminal or both out of. Agreed, class, everybody? Now, at that point, what do I need to get? I need to get V2, correct? I need to get my V2 here so I can find out what V1 is here. You all with me? All right, well, what is this voltage? I think you can see it. What is it? What is V2? It's from the plus to the minus there. V2 would be what, people? It would be what? That current 4, right? Or I2 in this case, I'm calling I2 coming out now, times what? 4 minus J2. Do you agree that that's going to be simply 4 times the quantity 4 minus J2? And that's the voltage V2. Everybody agreed? I'm going to leave it like this for now. How many see this? All right. Now, if that's the voltage here, V2, what is V1? Less turns, more turns. Turns ratio times V2, right? Went from less to more. You all see this, class? So it's by a factor of 2. So now I can see my V1 is actually 2V2. Or it's going to be 2 times the quantity 4 times 4 minus J2. I'm going to leave it like that for sure. That's V1, right? Please just watch this, make sure you see. I'm trying to do this as simply as I know how. Now, what's the voltage here? In your own words. Do I know the current into that resistor? Yes, right? It's the current. What? 2 amps times 2 ohms or 4 volts. How many see this? This is not hard to see, but you gotta be attentive. So this is plus to minus 4 volts right here. Right? Now take a look. Just listen. This voltage from here to here is a voltage increase of V1, right? This voltage from here to here is a voltage decrease of 4, right? So that means the voltage across the 12, V12 right here, would be equal to V1 minus 4 volts. Does everybody agree with me there? Before I plug in for V1? Everybody see this? All right. And therefore, V12 would be equal to V1, which is that. 2 times 4 is 8, so I'm going to leave it as 8. Times the quantity 4 minus J2, right? Minus 4 is going to be V1 too. And if I can carry this out, so that means it's what? This is going to be, here it's going to be 32, right? Minus J16 minus 4, right? Or what do I have there? 28, right? Minus J16 is equal to V1 too. Do you agree with me? And that's not polar, it's rectangular, but I'm just doing it this way so we're clear. Everybody see this, class? Can you all see it in the far? Guys in the room. Isabella, can you see it that far away? All right. I'm kind of amazed that some of you can, but I'll take your word for it. Anyway, V12 is there. Now that's the voltage right here, correct? Right? So how much current is flowing there? Just take a look. that voltage divided by 12. Do you agree? How many see this? It's not hard, right? If we have the voltage here, the current here, call it I12. I12 is just equal to that voltage, 28 minus J16 by 12. Agreed? It's going to be a number. Now, you can see that the amount of current coming this way, right, is going to actually be, if you think about it, you can just write a current equation. This current is equal to this current minus or you could say that the current, depends which way I want to take it. Since I've got that much current going this way, you could say this, just label it as I source right there, and you could say that I source right there, I source plus 2 minus I12 equals 0, or you could say I12 here minus 2 is equal to I source, and I12 is right there. Y'all agree with this? Yes, sir.
Would it not just be easier to source transform, combine your 3 resistors?
Remember, we're after VS, aren't we? We are looking for VS. We don't have VS, right?
Okay.
See, that's the goal. We want to get VS. That's the reason I'm working backwards. That's what he asks in the problem. He wants for VS. Now, do you all agree that this is going to be IS right there? Right? With me? So once we have IS, that's here. Just look at this. That's 2 ohms. VS would be equal to what? It would be IS times 2 plus V12. Do you all see this, class? How many see this? You all see what I'm doing here? I'm just working backwards and incrementally. If I can get this current, I can get this voltage. If I can get this voltage, and I have this voltage, I can get this voltage. If I have this voltage, I have that current, right? And you keep on working backwards towards the source. Are we clear? If you want to finish it up here, just do it. What is? You've got a quiz in a second. But you all see that this right here would be I source. And then if you just take I source times 2, you get the voltage there. Add that to V12, you have VS, right? All right, come on down.